Howdy everyone, welcome to episode 5 of Devlogs. Today we're going through lesson 4 of WWise. I'll also be showing you an interactive menu I made for my class, Advanced Topics in Game Design. The menu I made demonstrates a reward and setback system for video games that I plan to implement into my senior project. It is also my first steps into creating C# scripts in Unity, so look forward to that. But first, we'll dive into lesson 4 of the 301 certification. We'll talk about posting events from a script, posting events using WWise types, posting events from animations, posting audio input, and reference scripts. Okay, let me jog y'all's memories real quick on last week's episode because this preface into the lesson is conveniently addressing something I discussed previously. I talked about wanting to make a WWise demo reel, but was struggling with something that was time-consuming to troubleshoot because an event I created for an enemy called a Growler was a nice distance away every time I entered play mode to test WWise's sound integration. I said I wanted to rather create an event for the player's footsteps, which could be troubleshooted right at the start of play mode, but couldn't find the event in Unity that I needed to tie my WWise event to. This paragraph right here seems to be addressing that. What it's saying is that Unity projects often contain custom scripts for unique cases, like connecting sound into a certain point of an animation for the player's footsteps. This would require a custom script, and cannot be defined with predefined properties that you would see in a Unity or AK component. For those who don't realize, we'll be getting into Visual Studio this video. If you realize and are panicking, don't worry. I as well am very new to this software, and we will be experiencing the first steps together. Visual Studio is an integrated development environment. It's a software we integrated into Unity when downloading the required assets for getting certified. The software is typically used for developing computer programs, such as websites, web apps, mobile apps, and more. In Unity's case, Unity is built to support scripts opened by Visual Studio. Visual Studio works externally on its own interface, yet Unity can receive scripts from it and open them. Rather than explain this, I'll show you how. The lesson starts with posting events using a property called WWise types. WWise type, my bad. I've loaded the lesson 4 scene 1 scene in Unity and am going to create a custom component. Previously, we've solely been using AK components for everything, which contain the pre-made scripts Audiokinetic has so graciously given us for simpler events in games, such as for when entering or exiting a trigger, a sound bank is loaded or unloaded. Remember that? I'll recreate the instructions in this video. Watch as I click Player Object, navigate to the bottom of the inspector window to click Add Component, then scrolling to the bottom and past all the AK component options, get to the new script option at the bottom. The lesson warns us not to change the language property from C# script because that is the programming language this lesson is based on, so make sure not to change it. When naming the script, it also warns to check for spelling mistakes because correcting these can be a difficult process later on. When ready, I click Create and Add, and in the bottom right, a custom script is generated. By double-clicking the post-WWise event component we created, Visual Studio will open up and display some default code in the code editor. This is prepared for you in every script you make. The lesson shows us how this would look and also notifies that it will be showing script images in the lesson certification that look like the image below it. We're going to break down what you see, but I want to do it on a screenshot of my code editor. This is still Visual Studio, I just have a darker theme that I prefer over a light one. At the top of our script in lines 1 through 3, these are called namespaces. The blue word using you see at the front is what defines these lines as so. Namespaces are a collection of classes that make writing scripts easier. Line 3 says using Unity Engine. So I would assume all scripts we create from Unity are using a bunch of functionality features from it that can be used in this script. If we were to delete that line, the code would not function in ways that the namespace enables us to. Moving down, we get the classes. Classes contain variables providing a varying assortment of functionalities, all of which are set to a container that Unity will derive script from. To clarify what your class is in this scenario, look at line 5 where it says post WWise event. This is our class name. As for our container, look over to the colon that defines our container, monoBehavior. MonoBehavior is a base container recognized by Unity, assuring the variables we create will transfer into Unity. Variables get placed in between the curly braces, letting the class know what parts of the script belong to it. This is important because these variables will determine how your script functions when it's transferred into your script within the inspector view of Unity. Look at all the components in the inspector view to see what I mean by variables. Currently, our custom script at the bottom has no variables, unlike other components above it. When we create variables within the class in Visual Studio, we will then have variables appearing in our component, just like the other components. Before moving to functions, if you find yourself confused and need to try and understand this before moving forward, the lesson has provided links to a Unity tutorial site that goes over scripting basics. I will put a link in the description, or you can go to the part I am at in the lessons and click on the blue vocab terms to be redirected. Now, let's talk about functions. These are pieces of code called upon by Unity or other scripts. A function starts where you see these conveniently labeled words that characterize how a function is being executed. Void is a type of return, where whenever a function completes itself, it does not provide the results of a function to its caller. For example, where were you standing in a scene versus where you are standing a frame later? The word void makes it so that in this example, if a function were to update our coordinates each frame, the result of our updated coordinate would not be provided to its caller. It will simply finish its function and repeat if asked to do so. This is handy because we don't need to know what our coordinates are every frame. We are simply taking advantage of the fact that this function is purposed for updating our player position frame by frame. The value isn't important to us, but the ability to move and for the game to recognize that is, making void a suitable return that prevents the results of a function from being transmitted to its caller. So, return tells us how the results of a function is being returned to its caller, which the caller is our script from Unity and whatever object and event it later will get tied to. Next up is the type of function itself, which we have two right now, start and update. We can read the comments in our code editor to see what each function's purpose is, which are the strings of text in front of the double forward slashes. When you forward slash a line of code twice, it will turn that text into a single line comment, making it so all text after those slashes will be ignored by Unity and solely meant for being read. Our start function is purposed for initializing the script upon being called. The update function will then take place and loop itself as many times as needed, every frame while the script is actively calling this function. Next up are methods. Before we break this down, I will say that I do not care for the way it is defined on this page because it uses different words for the same term, I think, and that feels a bit misleading. Methods contain inputs, though I prefer to call these parameters, which is an alternate term. Parameters are inside the parentheses and can reference variables outside of your method and be used within a function. Method is also another word for function, which is where I personally see this becoming confusing. A function or method is the overall chunk of code that produces a result to be returned. Please correct me if I am wrong and if you're listening, otherwise this description makes the most sense to me. Moving on, these curly brackets define the start and end point of a function's code. The code itself will be located in between the brackets. Everything within that space shall define what your function should do when called upon. Before creating code for your function, we need to provide information about the event with a property. This will be done on a new line of code, but first, the lesson breaks down the three parts that make up a property. The access modifier determines whether or not a property is visible for properties in the inspector view of Unity. If you look in the inspector view right now, you will see that in some of the component boxes, there are some grayed out properties. These are not usually present in the component boxes. However, I clicked the filter drop-down button in the top right and enabled the debug view, which shows private properties within the scripts of every component. These properties don't show up in the normal inspector view because of the access modifier not being public, rather private. This makes it so Unity will not show them, and those properties cannot be modified, even when visible in the debug view. Moving to the green box, we will be defining the WWise types class. Remember, our goal is to create a WWise type event class variable, just like a property you would see in an AK component. Typing out capital AK period WWise period pops up a recommendation for a potential class type. Conveniently, it offers the event class type, which I accept, though the lesson notes there can be other class types that tackle different features you can make a script for in Visual Studio, such as states or real-time parameter controls. Don't worry about understanding those for now, and let's just focus on the event class type and what it will later do. The lesson tells us that we've declared the type of property, but that we still need to give it an identity that will appear in your component's view. Here, you'll list the name of your property, providing a single space between your class type. Providing a semicolon is the C# programming language's way of stating when your line is ending. When you do this, go to File and click Save Assets, or use the shortcut Control or Command +S, depending on what platform you're using. When you click back into Wise, you can see the property is being recognized and shown publicly by Unity in our post-Wise event component. Since we haven't written any code for the function, it will not do anything, but we're getting there. Also, make sure to double, triple, even quadruple check your code. Mine was formatted incorrectly, and it took me a solid 30 minutes to figure out what was wrong because I simply forgot to put a curly brace down in a certain spot. Not having proper formatting can create weird and misleading error messages in the code editor, and sometimes tell you confusing things when realistically the problem is just a missing or incorrect character. The box created in our component that we can put events into is called a drawer. We can put game objects in there, like we've done before, and whatever the event is scripted to do will do something to the target object. We're not there yet because we haven't coded any of the functions, nor have we coded a function to even post the event when we enter play mode. We'll start with coding our script to post the event, which brings us to the start function. If you look at the comment here, you'll see that the start function runs once and it's for initialization. That means it posts the event, and then if any changes happen to that event and those changes need to be communicated to Unity, that happens in our update function. Remember that when typing code for a function, we need to be in between the curly braces. Once your cursor is in the correct spot, you type my event, period. When placing the period, a list of suggestions should pop up that shows a list of available functions for your WWise event class that we can use. It didn't do so for me, but that won't matter because the lesson tells us we can type it in manually. After the period, we type post and 2 parentheses. We can hover our mouse over this and a message will show, telling us the purpose of this function as well as what it needs to function properly. Read this yourself and pause to maybe test your understanding before I tell you what's going on. What the lesson boils it down to is that there are 0 arguments provided for this function, which means we lack game objects this event will get posted onto. We will be giving this function a sound to post onto whatever game object this script is later applied to. Inside the parentheses, next to the word post, is our function call. This is where we provide an argument to call upon the function. I'll type in game object and add a semicolon after the parentheses, ending that line. Save your script after this, and we can now post events from the Wise Picker tab onto our script. These Wise events contain audio that can now be assigned to game objects. We dragged in a random audio event, but this is just to test if our script is working. Listen as I load the scene, and you should hear the sound of a rock being destroyed at the start of play mode. Sorry. If you are following this on your own and it didn't play, run back through the steps and look over your code. For those just soaking in the information, we have officially created an WWise event script with the function to recognize Wise audio events and post them onto game objects the component is added to, which in this case is our player game object. So it's cool that a sound plays when the game loads, but we need this event to be able to do something a little more precise. We want to post the event at a critical point within an animation that requires sound at a specific instance. This means we will be applying an animation event to what's called an animation clip in Unity. These animations can derive from Unity itself or other programs like Maya or 3D Max. Regardless, I have opened up a new scene, and what's cool is we can apply our custom script to an object in a different scene. The lesson tells us to add our post-Wise event back to the player game object. Instead of the rock destruction sound, we will now be focusing on the player footstep event, which contains a random container from Wise. The random container has various footstep sounds that play in a random order, which creates variation. Our return is currently set to post our function at the start of play mode. We're going to change the word start, as instructed in the lesson, to play footstep sound. This means Unity will no longer call the event at the start of play mode, and we can now begin specifying when exactly we want this event to be called. Since we are trying to apply the player footstep sound to an animation clip, we need to open the animation window. This is done by clicking the Window tab, going down to Animation, then clicking the Animation option to open that window. If you've never opened this before, it may open as a separate window and you will have to drag it into a section of Unity to add it to one of your views. The lesson puts it in the bottom view as one of the tabs. An animation clip stores a sequence of changes made to the properties of the game object that's being animated. Your properties appear in the property window, which is hard to see with that yellow text, but those are all different parts of the body and properties that you can adjust for each body part, like scale, rotation, position, and more. Animation events are represented by the white markers you see beneath the timeline, signifying when these events will occur. When the time marker reaches these events, they get called to action. We will be calling the play footstep sound function at a point where the player's feet touch the ground during the sprinting animation. In order to see where the feet touch the ground, we can drag the time marker back and forth to simulate different frames of the animation. The diamond markers you see beneath the timeline are keyframes that represent changes in various properties that the property will transition to, when instructed to do so. You can see the animation is nice and smooth when I click play. We want to place the sound of the footstep at a point where the player's foot comes into contact with the ground. Dragging the time marker to the 5th frame, you can see that the right foot comes perfectly into contact with the ground. Right-clicking the event line brings up the option to add an animation event. When doing that, an event marker appears and the inspector view shows a function drawer for the event at the 5th frame, which is now highlighted blue. By clicking the drawer where it says "No function selected," we can add the player footstep sound function and will now be ready to test out the sound. Keep in mind, the footstep should only be playing for the right foot and will play a variety of footstep sounds from the random container made in WWise. Everything worked out. I'll now show a video of me going through this whole process, this time for the left foot. And so, our random container of footstep sounds is called to play for the player game object's running animation clip. After this, there is a bonus section in the lesson that talks about using the AK microphone script. I went through it, but did not have a microphone at the time to showcase with. But basically, this event is set to recognize input from a microphone, and when you input a certain level of decibels, an action will occur. If I had a mic plugged in that could recognize input, I could show you a video of the character swinging her sword each time I shouted into a mic, but I sadly did not have the time to set that up. You should check it out in the lesson if you're interested. Be warned, you'll want to know how to navigate WWise to do this, which most likely will mean having completed the 101 certification. This is the end of the lesson. The final section of this lesson contains reference scripts that you can copy and paste into your code editor if you're struggling. I would only do this if you're truly lost, and if you do it, make sure you go back and figure out why your code was wrong. Otherwise, what are you learning? That concludes Lesson 4 of WWise. The code editor definitely was not as bad as I thought. As mentioned at the beginning of this video, I said I would show you some of what I was doing in my Advanced Topics in Game Design class. In my presentation for this class, we showed our progress towards a project that demonstrates what we've been discussing in the past few weeks. Since this presentation was done during an early stage of development, it was required that I needed to be able to communicate to the playtester what features I was focused on and what features were in the works. Providing context in these scenarios is what led to some pretty nice feedback while showing off the menu. Since this was my first time coding with Unity, I focused on a simple button system that would allow people to click the nodes and equip or unequip skill points. This was as far as I got, given the short amount of time, and I had to design a somewhat intuitive menu that provided proper visual feedback for the user. This function here lets Unity recognize when a button is enabled or disabled. Depending on whether the button is enabled or disabled, it adds an integer value of plus or minus 1, which at the moment doesn't visually mean anything. However, I plan to have that value textually show on the menu, as a means of visual feedback for the player. This skill point system rewards points based on levels in a game being completed. The catch is that you can earn different amounts of points based on the difficulty that you're playing on, as well as how well you perform each level. This creates variability because you either will or will not acquire every skill in a playthrough, plus you can lose skill points if you were to lose all your lives and have to use to continue. There's a lot more that needs to happen graphically in order for a lot of what I'm talking about to be more clear, but with the time I had, I focused on getting the menu to function so that when you click the nodes, they'll turn on or off. I relied on my communication skills during playtesting to make the player aware of what was in the works and what I had focused on, which went well and resulted in interesting feedback that I tried very quickly to jot down. After a few rounds of playtesting between individuals, our class met back at the table and we talked about some papers we've read in class that we felt were best applied to our projects so far. This called back to topics such as player types in games, the hook model, extrinsic and intrinsic motivation, and more. That concludes most of what went on this week. Thanks for listening. I'll see you in the next video. Have a good one.